Perfect. I'll get you guys all caught up after we talk. Okay, so today is bivariate data, which is just regression analysis. It's just a fancy word for two different variables on an X and Y axis. So we call that the regression analysis. All right, and these three formulas you have got to know. I think they're on the formula sheet, but we're going to use these a couple times today. So have these somewhere handy dandy. You should have a formula sheet nearby. Make sure it's on your formula sheet if it isn't. So this is the prediction equation line. We call it y hat. So whatever the y variable is, we actually name it. So if it's protein, we say protein hat. If it's calories, we say calorie hat. If it's distance, we say distance hat. Equals b sub naught, which is the y-intercept, plus b1 times the x value. So that's the slope times whatever the x variable is. And we name that too. So if on the x-axis you have fat, you say b1 times fat. And then to find the y-intercept, we can actually use the average of the y variables minus the average of the x variables times the slope. And to calculate the slope, we can say the correlation coefficient times the standard deviation of the y over the standard deviation of the x's. So these three we'll come back to a couple times. And you will need these when you do your AP questions. I tried to do this video about the rainy days and the sales data on umbrellas, and it would not let me pull it up. I'll try and post it for you guys, but it said I was down to 2 videos left on the Harvard report. And so this one was a cool video, but we won't replay it. I don't have a review packet for you, but I do have those quizzes in mycollegeboard.org. And then I will post the regression quiz code. I haven't found it yet, but I know it's there. Please recall, if Julia Brady were online right now, she would say correlation does not imply causation. She always remembers to say that. Whenever we say you have correlation, it doesn't mean one thing causes another. It means you can find some kind of an association between the two variables, okay? And then when we get to next class, we'll be talking about planning a study. That's one of my favorite lessons. Moving on. Okay, so your residual values are the distance from the actual data point to the regression line. So if the value is above the regression line, you have a positive residual. If it's below the regression line, that distance is a negative residual. And again, these are just your slope formulas, your y-intercept formulas. So I'm going to move on. Okay, do you remember when we did the distance and the fares way back, probably way back in October, where we said, if the distance from, I think all these are from Atlanta Airport. So if the distance from Atlanta, yeah, they are, from Atlanta to Baltimore was 568 miles, the fare would be $219. If the distance from Atlanta to Boston was 933 miles, the fare would be this. And what we did is we went into our calculators under the stat edit, and I put all those values in L1 and L2. So L1 is my X values, my distance, and L2 is my Y value, my fare. And this is a good time to talk about response and explanatory. So the Y-axis is the response, and the X-axis is the explanatory. So distance is explanatory. In other words, distance is not affected by price, but price is affected by distance. So the price is the response to the distance, but distance does not respond to price. So we put them in the calculator, and then we went to the stat plots and we put it on, and I did a regression analysis using the on button, the first dot of the type, and then the L1 and L2. And if I hit zoom 9, I should get this scatter plot with the regression line going right through it. So again, if I hit trace, that will pull up any one point on the line. And if I keep using my side, so this point has a positive residual because it's above the line. And this point has a negative residual because it's below the line. And it appears to be the point that's the farthest away from the regression line. So we call that a possible outlier, and it's at 683, 141. So I can see it's right there at Kansas City. So I'm thinking Kansas City may be an outlier because it appears to have the largest residual, even larger than this one and this one. Seems like it's that one right there. So I'm going to go through these quickly because we've already done this entire worksheet. So I circle Kansas City. That appears to be the outlier. The explanatory variable is the x-axis. The response variable is the y-axis. So explanatory is the distance, and the response is the fare. And then when I go in my calculator, if you go to the stat calc, we did number 8. 8 was linear regression, A plus BX, that's for statistics. Don't do the number 4. If you go to stat calc number 4, it's also linear regression, but that's AX plus B. So we always use the 8. And then I have my variables in L1 and L2, and I calculate. And here's my regression analysis line. It's A is 1.77.2, and the slope is 0.0786. And the R squared is the coefficient of determination, and the R is the square root of R squared. There's your correlation coefficient. And one thing to remember is correlation does not have any units whatsoever. So you should never see units on correlation. I'm going to pull up the chat to see if anybody's talking to me. Nope, nobody's talking. Okay. So we just found all of that in the calculator. So where it said, what is R squared? That would be 0.482. Undo. And I could also use the correlation and say, if correlation R is 0.694, I could square that and get 0.482. And then remember what R squared means. R squared is the correlation coefficient, and we can say blank percent, 48.2% of the variability in the, and we always say the y-axis first, the fair, is explained by the change in the x-axis distance. So you're going to want to lock that in. Whenever you have a, what is it called again? Coefficient of determination, the R squared, this is where you say blank percent of the variability in Y is explained by change in X. Okay, that is not the same as correlation. Correlation is the strength of the association. Find the slope of the regression line. So I'm using that formula I showed you in the beginning. The slope is B1. It's the correlation R, which is 0.694, over the standard deviation in the Y's over the standard deviation in the X's. And here's the standard deviation of the Y's, and here's the X's. So we could find B1, and if you look on my printout, B1 was 0.0786, and that's exactly what we got using their work as well. Okay. Chat room, any questions? It's so hard to move everything around to get everything in the right side. Nope, I don't see any questions in chat, so I'm going to keep moving. And then they said, is the linear model appropriate? Well, here is the scatter plot. And I would say, sure, it's sufficiently boring. We keep saying the word boring. I noticed that when they check it on the exam, they want you to say there is no pattern. So we say, yes, the residual plot is boring, but they want us to say because it shows no pattern. How strong is the model? If the correlation coefficient were 0.694, where did I see that? It was here somewhere. It's on the other page, I guess. There's R squared, so you could take the square root of 0.482 and get 694. And we consider that to be fairly strong. Remember, anything over about 0.5, 0.6 is fairly strong. Anything really close to 1 is super strong, and -1 is also super strong. We already talked about outliers, Kansas City. Okay, so the equation of the model. So I need you to learn how to read these mini tab printouts. So whenever you see the dependent variable is fair, then the distance has a slope and the constant is the y-intercept. So we would start with fair hat equals the constant or the y-intercept 177.215 plus the slope 0.0786 times the x variable distance. And so then they say predict the airfare for a 1,000 mile flight. You know the distance is 1,000 miles, so you just stick it in there and you get 255.81. Now remember, that's the prediction for a 1,000-mile flight. That's not the actual cost, it's just the prediction. It may have a positive, it may have a negative residual. Okay, I'm not seeing anything, so I'm watching your faces and I'm trying to keep an eye on the chat room, and it doesn't seem like you guys have any questions, so I'm gonna move. Then what they did is they flipped it and they said, let's make the dependent variable distance, which is kind of totally crazy to me, but they said, can you do this? Yes, you can. And notice R squared doesn't change, nor will R, because we said if you change the axes, you still have the same association between the variables. It's just flipped. There's no difference in the numbers for R squared and R. But now the new equation is going to be distance hat, because distance is dependent, equals negative 644.287 plus 6.13 times fair. Okay, so even though we switch the x and y axis around, it doesn't matter. The equation will change, but the r's and r squares will not. So then it says, how far does this model suggest you could fly for the fare you estimated in number 5? So in number 5, we estimated a fare of 255.81. So if we put the 255.81 in, we get about 923 miles, which is kind of close to 1,000. Okay. Questions? Okay, moving along. So here's what we mean by a not boring residual plot. If you know that this is the residual plot, and you can usually tell because there should be a line right through the number 0 on the y-axis. It's saying that the residuals from the line, all of these points have positive residuals, and all of these points have negative residuals, and all of these points have positive residuals. There is most definitely a pattern. I can see it looks like a wave. So because the residual plot has a wave, you cannot use linear regression for this. And a linear model is not a good choice. And obviously this one has a super wave. So again, a linear model is a poor choice. That's what they want you to look for. Be careful. In the 31 questions that I've assigned you in the AP College Board, there's about 3 of them with residual plots, and it is obvious there's a wave or a pattern. So look for that. Okay, so this one says, in the scatter plot of y versus x, you'll find the least squares regression line superimposed on the plot. So there's the LSRQ. And they're saying, which of the following points do you think has the largest residual? Point A, B, C, D, or E? You guys can either talk to me. Actually, everybody keeps muting. Do you all mute yourselves, or does it just naturally happen? You can type it in the chat room if you don't want to talk. Who wants to tell me which one of these points, A, B, C, or D or E, has the largest residual?
Gianarella, is it A?
Yes, yes, it is A. I see it. I see you just chatted it. Okay, yes. Thank you, because obviously A is the farthest from the line than any of the other points. So that definitely has the largest residual. Would you say it was positive or negative, Jake the Snake?
It's positive.
It's positive. It's above the line. Well done. Okay, and then this is one on weed killers. So this is an actual free response from the 1998 exam. And it says, in an application of a certain type of weed killer, 14 fields containing large numbers of weeds were treated. And the weed killer was prepared at 7 different strengths by adding 1, 1.5, 2, 2.5, 3, 3.5, or 4 teaspoons to a gallon of water, and then they sprayed the fields. So here's the mini tab, here's the residual plot, and there's the questions A, B, and C. So what is the equation of the least squares regression line given by this analysis? So look up in the mini tab and just call it out to me. And don't forget to use actual words. So we're going to say percent killed is the dependent variable, and number of teaspoons is the explanatory or response variable. I'm sorry, explanatory variable. So the hat is always the dependent variable. Start with that. I hear it clicking, so somebody's typing. It'd be easier to talk. The only people whose mics are still muted are Brandy's and Mallory's.
So for the y hat, do you want us to use like a word, like?
Yes, always use words for the.
Yeah. So the y hat is dependent variable.
Yes.
So that would be percent killed.
Percent weeds killed, right? Okay, and then the rest of it's easy. What are you going to put in for the y-intercept?
Negative. Oh.
It's always under the constant. So which number is the
Okay.
constant?
Negative 20.59.
Yep, yep.
58,
And then what is the the slope?
24.392.
Right. And then what is the x variable called?
The strength of the weed.
Right here. This is whatever the slope is, that's the
okay.
x variable right there.
Okay.
So number of teaspoons. Okay. So then it says if someone uses this equation to predict how many weeds, what percent of the weeds will be killed at 2.6, you would just put the 2.6 right in the number of teaspoons right in that equation. Why is this not? Oh, I flipped it around for some reason. Let me flip it back. It's the same answer, but for some reason I don't like that at all. Cut. And then, so this question is, would you expect that your prediction in this equation up here is going to be too big, too small, or shouldn't even be made?
Should it be made since it's a...
Go ahead, Jake. I hear somebody typing. Jake, you kind of cut off in the middle of, you said shouldn't be made because why?
Because it's a exponential curve.
What do you mean by that? Be a little more specific with your words.
Well, the graph is a curve.
Okay, so that's what there's definitely a pattern in the residual plot. So you shouldn't even be using this to make a prediction. Obviously, these mini tab numbers are no good if your residual plot has a bend. So you're right. We shouldn't have even used it. But the way I see it is, if this is the small teaspoons and this is the large teaspoons, for anything in between, you're going to get negative residuals, and anything really small or really big, you're going to get positive residuals. So you're right. They shouldn't even be using this because the pattern is there. Let's see. This is on air travel. How many commercial aircraft were flying in the US from 1990 to 98? And they're making the year 1990 the year zero. So this one would be the year 0, 91, 92, 93, 94, 95, 96, 97, 98. What do you think of the residual plot? Is that appropriate for a linear model? Yeah, Brandy, I agree. It definitely looks like there's no pattern. It's sort of boring. They're kind of scattered above and below. One of the things to look out for also is you never want a residual plot where you have a whole bunch of points in the front, and then as you get towards the end, you only have one or two. Remember, we called that sort of a necking of the residual plot? You don't want to see that either. That's called homoscedastic. I can never say that word. I always have to say it several times. But you never want the residual plot to start with a bunch of points and end with just a few points as you go forward, or the opposite way as you go up. So let me get rid of all this. Okay, so a linear model is appropriate. I agree. There's no pattern in the residual plot. So what is the slope? Somebody tell me what the slope is based on all of this. So Morgan says 2939. Anybody else? Does everybody agree? And Brandy says 23. So remember, the slope is always the second one. They do these backwards. They always give the y-intercept first as the constant, and then the slope goes with the x variable. So the x variable was years, and then the y variable is how many commercial aircraft are flying. So right, it is 233,517, and the units on that is how many aircraft per year there were flying. So the value of the intercept is what Morgan said. That's the 29, 39, 93. Okay, and so when they say interpret the intercept in the context of the situation, what they're saying is the y-intercept is always where the x value is 0. So the x value is 0 at 1990. So I guess we could say something like in 1990, we expected there was about 29, 39 aircraft flying. Okay, now the prediction equation. I really need you guys to speak this one. So what goes under the hat? What are we calling the y variable? It's up here somewhere in the body of the problem. We know the x variable is years because it's always with the slope. So what's the y variable called?
The number of commercial aircraft flying in the United States.
Yes, very good. And I kind of abbreviated mine, but you're absolutely right. It's the number of commercial aircraft. And then we would do the constant would be, see, I did this backwards again. The constant should come first, the 29, 39, 93, followed by the slope times the x value. And so if they're saying, what was it in 1992? I'm going to put a 2 in for my x value. So let me get rid of this. So we predict in 1992 there should be about 3,400 aircraft flying. And then you find its residual by saying, okay, so in 1992, let's see if this is 1990, 91, 92, it looks like this is about 40 more than what we predicted. So you would take what we predicted, 3406.96, and add 40 to it. And that would actually tell you what the actual value was flying in that year. So it had a residual that was positive, so it was actually more than what the prediction was. If the residual were down here, we would subtract it from that number. Are we good? Okay, moving along. I'm not going through all 25 slides. Oh, okay. So this one is talking about points of influence. So if you look, P is way out here beyond the X variables, the X values of these other points. So these X values start somewhere around 0 and go to about 15. And then this P value has an X value of about 30. So that's going to be a point of high influence. If it goes high, it's going to bend the slope way up. If it goes low, it's going to pull the slope way down. Do you guys remember we talked about points of influence?
Mm-hmm.
Well, let me show you something. We did this where they said, okay, so this is, let's let this be an outlier, right? So you can see how all these black points are really tightly clustered. If I try and slip it in between those black points, the line barely moves. As long as it's within this X and this X value, the line barely moves. Now watch what happens if I go right in the middle and I go way up high. You can see what happened. The line rose up, but the slope stayed about the same. And what if I go way low? The slope still stays the same, but the whole line is kind of pulling down. But watch what happens when I go outside and then go way low. Look at how the slope bends. So that's what a point of influence does. If it's way outside of this X range right here, why do I keep moving my graph? Then it's going to really have a huge impact on the slope. So that's what this problem was all about. I just wanted you to know that P was a point of influence. And so it says, does P exercise a large influence? I would have said, yes, it does, because it's so far beyond the X values of the other points in the scatter plot that it's going to do something pretty big to the line. Now, if it's really close to the line, like if P were right down here, it's not going to bend the slope because it's going to actually catch the line. But for every bit it raises up or pulls down, it will have an undue influence on the slope of that line. So that's the only reason I put this one in there. Okay. And then they said, oh, we actually discovered that the person who was recorded as P was actually where Q is. So Q is the actual value of how much they studied based on how many hours they worked. And remember, P was way up here in the last graph. And then they said, oh, sorry, we recorded it wrong. It's way down here where it belongs. What is Q going to do to that influence, to that line? Remember, the line looks something like this. What is Q going to do to that line?
It's going to bring the end of the line really low.
It is. It's going to pull the slope down towards it. It might not go all the way to it, but it's going to pull it down from where it was to closer to Q. So that's what a point of influence is. Okay, anybody want to do another mini tab, or are we so over it? Mallory's so over it. Mallory, SLAP, S-L-A-P. Do you remember that stands for strength? Let me see if I can do that. SLAP is strength. Linear association. What does P stand for? Strength, linear association, and I cannot remember. Anyways, what would you say the strength of this equation is? Is it strong or weak?
Strong.
Definitely strong. Would you say that there's a good linear analysis based on these points?
Yes.
Yeah. And the association, is it a positive or a negative association? In other words, slope. Is the slope going to look positive or negative to you?
Positive.
Positive. And for the life of me, I can't remember what P stands for. I'm going to have to look that up. But when they ask you to describe it, try and use this acronym SLAP, S-L-A-P, and I will figure out what P stood for in a minute. But I'm going to move on. Okay, more mini tabs. I don't have answers to these, so I'm going to keep on flying. Okay, I am done. So in the My College Board, they want you to do the 31 questions, including 1 or 2 FRQs, not too many. And what I'm trying to do is have everything due on Sunday night. So even if I give it to you Monday or Wednesday of this week, I expect all of it to be due Sunday night, because normally we would have 2 to 4 days to do it, and that gives you at least 2 to 4 days for everything. So remember, next class is designing studies. And that's all I have for bivariate data. If you have any questions, you can email me or you can stay on the line behind. And I'll see you guys Wednesday. Bye, everybody. Great.
Bye, Miss Annabella.
Bye, Jake.